Hello, hello, hello. Welcome to STEMAIDE Insight Series, Day 2. Come on, ladies and gentlemen. I'm very happy to have you here once again. Welcome once again to STEMAIDE Insight Series, your number one STEM series webinar brought to you by STEMAIDE Africa at the first Saturday of every month. STEMAIDE is an edtech company that is on the mission of providing quality STEM learning materials and services to every African on this continent. In fact, at STEMAIDE, we say reinventing the future, a future where you and I have practical science, technology, engineering, mathematics at anywhere we find ourselves. At STEMAIDE, once again, we say reinventing the future. I would urge you to head on to www.stemaide.com for more information on STEMAIDE. Today marks the day 2 of our 3-day online workshop, and I hope you are already getting crazy ideas within these few days that we have just been live. Ladies and gentlemen, today is also a remarkable day. It's a very happy day, and I believe you and I are going to build amazing projects together once again. Ladies and gentlemen, today we are going to jump in onto the push button system. In fact, before I start this, I have something for each and every one of you. I recommend you to hit on the subscribe button to this channel. Also, I recommend you to head on to www.stemaide.com for more information as in how to reach out to STEMAIDE. I also have something here called a STEMAIDE Coder Kit. This is all-in-one kit, and this is one of the kits we are using for this live session, and we also use the software Tinkercad. And if you want to build all the projects you are going to build during this live session in reality, if you want to practice them in reality, I'll head you to go for STEMAIDE Coder Kit. Visit stemaide.com, and then you can have more information as in how to get your STEMAIDE Coder Kit. And before that, right in the bio or right in the description to this channel, I have dropped all the links and all the Google Drives that you would need to be able to follow us on this practical section. So make sure you look into the description of this stream, and then you can get all your Google Drives, folders, and files that you would need, and all your codes and everything that you need, all your environment you need to set up, to go live, and then to be able to do what we are doing here. Thank you once again. My name is Lapi Moeti Joseph. I'm a technology and a fintech educator. I specialize in the field of STEM, robotics, and financial technology. I am going to be your host for today and tomorrow, once again, our 3-day online workshop, and I hope you have an exciting workshop. In fact, I am excited to be your host. Ladies and gentlemen, let's not waste no time, and then let's jump in, family. Yes, so today we are going to be working on the smart push button system. A button where we push, and then it bears a sound, and it also turns on our LED. Come on, this is an amazing system. So I hope you are not going to delay. Just go get all your environment set up right in the description below. All the links are there, and then we can head on to start our project. So before we start, let's talk about the kind of tools and materials we are going to be using within our project. So just as you can see, I've labeled them from the number 1 to number 6. Within the number 1, we have the Arduino Uno board. This is a microcontroller board. Yesterday, I described what it is. So this is a microcontroller board that we are going to be using to upload and offload our code. Every code we are going to write is going to be in the microcontroller board. And once again, we have the buzzer, which is our component number 2. This is a buzzer this is a component that produces sound. Whenever we trigger a signal to it, it produces sound. And it can be used to produce different kinds of sound, not only the normal sound, but different kind of sound. I remember we can program this to even sing happy birthday for us. Aside that, we also have the component number 3 being the push button. Push button is the kind of component we are going to use as our main switch here to be triggering the signal to our LED and then our push button and our buzzer on the circuit. We also have the LED. the LED, and then we have the resistor. These are all components we are going to be using, and then our LED is going to be outputting light. Our resistor is also going to be giving us some kind of resistance to avoid our LED from being bent. And this is the whole system we are going to build today. I hope you are ready to build something. Yes, and I know you are very, very ready. So without wasting my time, we're going to jump in onto our Tinkercad project, and then we can start to build something. So before we jump into our Tinkercad project, once again, I recommend you to get every description or every link in the description for this streaming, and then get all the environment set up so that you can follow us as we go along. Ladies and gentlemen, let's jump in onto our real-time building. Yeah, so I have with me my Tinkercad software. I believe you can see my mouse moving. You can also see everything here. And I've already built my circuit. I'm going to test my circuit and then make sure that you can also go through the same thing, build it, and then test it. So I'm going to be building this with you right here, right at this moment. Yeah, so let's not waste time. Let's try to test to understand what our circuit is really. So right away, I have my buzzer, just as I said. I have my LED, push button, microcontroller, and then I have my jumper wires. These wires are being used to connect. And then I have my breadboard. That reminds me, yes, this is the breadboard, and then this is where all the connections happen. So the breadboard is the component I've highlighted. Let's right away start to stimulate our project here. Yeah, so to stimulate the project, I have the stimulate button, just as you can see here. And this is the button we are going to use to stimulate our project. So right away, I've already built my project, written the code. So when you come to the code section, you can see my code already being written. So I'm going to make sure I start my stimulation. So I'm going to click on stimulate. And as you can see, my project has started simulating. So I'm going to first press on the push button to see what happens to my LED and what happens to my buzzer. So I recommend you pay rapt attention to my LED and especially my buzzer. So right away, I press on the push button. You can see my LED changing color or being lighted. So as I press my LED, it's being lighted. And then that is, if clearly if you can hear my buzzer, it's beeping. If you have a look at it very, very well, it's beeping. That means that my circuit is actually working. And what do we normally use these systems for? These systems are normally used in homes where we normally use the doorbell system. So probably you go to someone's house, you see a doorbell, and then you get to press the button. It starts to beep or make sound, and then also practically some people even go to the extent of adding LEDs or light to their doorbell systems, and then it starts to glow light for them to know that there is someone at the entrance. Yes, this is what I mean. So this is just the simple system that our doorbell systems have been built on, and we are going to build this. So let's start to build. Right, so I'm going to stop simulating my code or whatever, my circuit. So I'm going to press on the stop stimulation, and then right away I stop stimulating. So I'm going to come back again, and then I'll center this. So I'm going to be building this simple circuit here with you. Right away, we start with our Arduino Uno. Just as I said, the Arduino Uno is a microcontroller. So it's like a small computer that can contain code and other stuff. So we write code on it. We can upload and offload code on it. So I'm going here right away to my component box, scroll to where I am able to get my Arduino Uno. So I can have my Arduino Uno here. I'm going to drag it and then drop it here. And I hope you are following the steps. Make sure you don't miss the steps. So I'm going to drop my Arduino Uno, and then let me first have to put this circuit up here so that I can have enough space down here. Yes. And then I'm going to leave it this way. Yes. I prefer putting somewhere here. So let me still drag my breadboard up. So I can put my breadboard up, and then I can put my Arduino Uno down. Now I have enough space to work with. So I have my Arduino Uno here. And then I'm going for my breadboard, because it's on the breadboard I'm going to be building everything. Everything is going to be built on the breadboard. So I will go for my breadboard, drag, and then drop the breadboard. So I'll leave it here. Now I have my breadboard here. I have my Arduino Uno here. I'm going to start mounting my components on the breadboard. Ladies and gentlemen, I believe you are following this process. If you also have the STEMAIDE Coder Kit, I would urge you to also open your kit, get the same component. I have my breadboard here from the STEMAIDE Coder Kit. This is the real-time thing. And then I'm going to get my push button. I have my push button, and then I have my Arduino Uno in the STEMAIDE Coder Kit. So right away, you can continue to build. Right away, you can continue to build the same project. So I'm going to start mounting my components on the breadboard. So right away, I'm coming to look for my first component called the buzzer. So I have my buzzer here. I'm going to look for my buzzer in my component section. Then I'm going to mount my buzzer on my breadboard. So I'm going to pull it right away here, and then I would want to drop it here. So right away, I have my buzzer being mounted on my breadboard, and I'm mounting it on the vertical connectors. Right away, I'm also going to look for another component, which is the push button I have here. So I'm going for my push button. So right away, I scroll down looking for my push button. I have my push button here. I'm going to drag it and then also drop my push button. And then I'm going to make sure my push button is crossing this bar. I normally like it that way so that I can have enough space up here and then down here to make my connections. Right away, I'm looking for another component, which is LED. So I have my LED here. I'm going to pick my LED and then mount it on the same space. I hope, ladies and gentlemen, you are following us. And then make sure you don't forget to do the same thing just as I'm doing. Also, don't forget to subscribe to this YouTube channel, just as I said. So I'm going to drag and then literally drop my LED right away here. So I have my LED here. Click it, drag it, and then I would drop it. I need enough space, and I don't want the LED to be on the same terminals with the buzzer, so I'm going to put my LED somewhere here. So one thing about the breadboard is anytime you put the power here, the power flows right away down here. So that means that the on the breadboard, anytime I'm putting the power here, I have the power flowing from here to here, and then it does not even move to the next line. It's always constant on that straight line that I've kept my power. So I hope you learned something very new today, and then make sure you still stay intact with our procedures. Right away, let's also continue. I'm going to get my last but one component being the being the resistor. So I have my resistor here, and then mind me, any resistor has its resistance capacity. So I would want to check the resistance capacity, and then here it's telling me it's 1K resistance. So I know I'm going for a 1K resistor. Right away, I'm going to drag this and then drop it. I'm dropping it on the anode of the LED. So I can now choose to change my resistance. Right away, automatically, my resistance is on 1K. So if your resistance is not on 1K and you want to change it, all you need to do is to click on the resistor. All you need to do is to click on the resistor, and then you can change the resistance value here. So mine is 1K. I want 1K, and then I leave it that way. Right away, I have my red LED. I have my resistor. I have my push button here, and then I have my buzzer. So I'm going to continue building, and now I'm done with mounting the component on the breadboard. If you are also going with the STEMAIDE Coder Kit, once again, it's still the same steps. Every component in the STEMAIDE Coder Kit is still the same, just as you can see on the screen. So make sure you follow the same steps. And also, if you don't have a STEMAIDE Coder Kit, I'll urge you to go for one. Get your STEMAIDE Coder Kit right now. Now, I'm going to pick my wires and then make my connections. So I have my buzzer, I have my LED, I have my resistor, and then I have my push button with my Arduino Uno board here. Don't forget, this is our master sheet, and then this is where we are copying everything we are doing. So I would want to put it down here for some neat work. Okay, let me rather change the connection so that I can have some neat work here. Good, 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 good. Now I have some neat works. Now let's dive deep and then start to wire our components. So I have my push button here, and then all I have to do is to wire my push button, and then if I can see my push button, one terminal is being connected to the vertical or the negative terminal on the breadboard. So right in this lane, I have my push button being connected. So I'm talking about this, which is my black wire. So I'm going to start with this first and then make sure I do the rest. So I'm going to put this, and then all I have to do is to come back to my circuit that I'm building. And then I'm going to make my connections. So click here, drag, and then put it on the right hole, leave it. Now, don't forget it's black, and then my wire is green. So I don't like the green. I have to change it to black. All I have to do is to click on my wire, come up here. You can see the green, and then I change it to black. There, my wire changes back again to black. So now I have my black wire, which is the same thing just as I have here. So it's the same thing just as I have here. And then I'm going for my second connection. My second connection is going to be on this red wire here, which is still the same push button. So one terminal of the push button is here, and then the other one is here, which means that my push button is on this lane. And then this one goes right away, if I'm to follow, goes to the pin number 11. Don't forget to make sure you are following the pin numbers, else you would mix your code. So it goes to pin number 11. I'm going to make sure I also drag mine to pin number 11. So all I have to do is to come back again to my circuit, which is the circuit you are building with me. And I'm going to drag it and then make sure it is on the pin number 11. So first, what I'm going to do is click on it and then drag. Then I would like to make a curve. I'm going to my pin number 11, so I would prefer to make a curve here again and then go up. Then I can have my pin numbers here. So all I have to do is to connect to my pin number 11, just as you can see. So I have my connection well made here. I connected it here right away up there to my push button. And it's red wire. So I want to change the color to red wire. I click here, come back again, and then make my red wire. So I have to click my wire first and then choose the red wire, just as you can see. Yes, so I'm done wiring my push button. I have to focus on the next component, which is my LED here. I'm going to focus on my second component, which is my LED, and then look deep into what my LED is being built on. So I have one terminal of the LED, hasn't it connected. I can see right away my LED is connected from here to this side. So I'm going to make that connection. So simple. And then don't forget about the LED. The LED has two terminals, which is the positive and then the negative terminal. So I'm going to be on the cathode, which is the negative terminal, and then make all my connections. And then when I'm done, I go to the anode connection, which is my positive terminal, and then I make all my connections. So I'm going to my negative terminal on the circuit I'm building, which is your circuit you are building right now. I have my master circuit here I'm looking up to, so I hope you also look up to either the master circuit, or if you also follow the Google Drive, I have everything in the Google Drive with all the images and all the connections, and I hope you're able to make your same connections. So I'm going to make my cathode connection. So right away I'm clicking, and then connecting it. So I would like to negotiate a curve and then still make another wire connection. So I'm going to choose this and then drag it to, so I'm going to come down and then connect it. So just as you can see, I have my connection wall made. Now all I have to do is to change my color to color. I have to check my color. So first is color black, and I'm going to change the color to color black. So I come and then I scroll. Deep, I have my color black, so I'm going to make sure my anode connection here is color black. So I dive deep and then I choose this. I choose and then I get back here and then I change my color to color black. Then I can now change the other wire to color black. Now I have my full cathode connection wall made. Now let me go to my anode terminal, which is the positive terminal of my LED. So I have my anode terminal here, and then my anode terminal here has a connection, and then let's look at where this connection moves to. This connection is actually moving to my pin number 13, right? So I have 12 here, that means it's 13, and then I'm going to make sure I make the same connection to my pin number 13. So I hope you are able to follow the same process to build your circuit. Now I'm bringing my resistor down so that I can have my resistor being connected to this side and then this side of the breadboard so that I can make my real-time connections. So I'm going to drag down, click on this, and then negotiate a curve. So just a minute. So all I have to do is to first make my connections. So I'm going to click on this, move down, click, and then still negotiate my curve. So I'm going to still negotiate my curve and then make sure it is connected to my pin number 13. So right away, let me close this and then make it again. So I drag it, negotiate my curve, click again, click for another curve, and then finally over there, click, and then I can now connect it to my pin number 13, just as you can see here. So now I have my positive terminal of my red LED to my pin number 13, which means that I am going to tell my Arduino Uno that my pin number 13 is connected to my red LED. So in the coding, I'm going to be telling my Arduino Uno the kind of pin numbers I've connected. So don't forget the pin numbers you are connecting, and then make sure you are on the right pin and then you are making the right connections. Right away, let's continue. Now, I have my last but one component, which is the buzzer. So I have my buzzer up here. Going to move deep. Now I have my buzzer. I have one leg connected, and then this side is also connected, right? So just don't forget about the buzzer. The buzzer and then the breadboard is connected linearly. So when I hover around this side, this tells me, the green tells me that my power is flowing right away from here to this side. So I'm going to connect the negative terminal of my buzzer to the negative lane of on the breadboard. So I'm coming down again, and you can see my negative terminal here. Sometimes I like to make it much easier. So all I have to do is to, maybe on my next port, I click, and then I try to negotiate a curve. Click again, click, and then I am on my negative lane on my breadboard. Ladies and gentlemen, I believe you are having an exciting movement, and then you are able to follow it just as I'm doing. If you are having any difficulty, don't forget to reach out to us on our WhatsApp lines in the description below. Also, don't forget to put your comments in the comment section below. Yes, so let's continue building our circuit. Now I have my negative terminal connected, and then I'm going back again to get my positive terminal. So let me have a look at the pin number my positive terminal have been connected to. I have my positive terminal of the buzzer connected to the pin number 4. So I have it connected to pin number 4. Have 3 here, and then that's 4 there. So I'm going back to my circuit, and then I'm going to connect my positive terminal to pin number 4. So I'm going to click here, and then I'll zoom out a little bit, try to negotiate my curve, and then find my ways. Click again, and then this time around I'm moving to pin number 4. So I zoom in a little bit, and then I'm on pin number 4. So just as you can see, I'm on pin number 4. I have my pin number 4. We're connected. Now don't forget, it's a positive terminal, and I don't like the color black, so I want to change it to color red. I click on my wire, and then I change it to color red. Sometimes I personally like to do it this way because it helps me identify the kind of wires I'm connecting to and the kind of wires I shouldn't touch. So I know just kind of positive and the blacks are actually negative. That's what my personality stands for me. So right away, I move on to look if I'm done just as it is being connected. But then I'm not done. I have one wire right away from the negative terminal to my GND on the breadboard. Sorry, on the Arduino Uno board. So I have a negative terminal from the breadboard here. I have my negative terminal from the breadboard here to my GND on the Arduino Uno board. And I'm going to make the same connections. So I have my negative terminal here. And then I click on it. And then I'm going to find my way to the GND on the, so just a minute. And make it very clear. Yeah. Now, I have the negative terminal here. I'm clicking on this, trying to find my way to the GND. And then I have the GND on the breadboard, so I click. Now, don't forget, all the GNDs on the breadboard, on the Arduino Uno board, actually works the same. It functions the same. GND simply means the negative part of the breadboard. You know, in every circuit, one of the most important things is the positive and then the negative terminals. So with our Arduino Uno board here, which is our Arduino R3 board here, the negative terminal is the GND, and then the positive are the pin numbers we have here. And then we also have power numbers here, which you have the V3, the V5, and then the reset, the IO, and then the analog digital pins. And then we have the digital pins. We have the analog pins here. So this means that if I'm making my connections and then I want the negative source of my connection, I just tap it to my GND. So that's what it simply means. So GND actually is the ground. So I'm going to change, as far as it's going to a GND, I don't like the color red, so I'm going to still change my color. Click on my wire here and change it to black. Now I have my connection well made. My connection might look a little bit scary to you. Don't be frightened. I hope you also find your way to make clear connections. And then don't forget, if you are using the STEMAIDE coder kit, once again, it's still the same thing, just the same process, make the same connections, and then kudos, you find your way out. Now, let's now start to go to the most important part and then the most exciting part, which is the code. Yes, the code is one of the most important parts, and then the most exciting part that we have to know and then we have to learn. Now, I wouldn't want to talk much. I have my circuit built, all my connections being made. Just as you can see, it's still the same thing here. I have my negative and then my positive wires being connected. So probably I have 1, 2, and then I have my GND 3. Then, so I have 1, 2, 3, 4, which is the same thing as 1, 2, 3, 4. So it's still the same thing. And I hope you don't miss any port. It should be on the same port at the same time as it's supposed to be. So I'm moving on to my code, and then this is my code here. Now, with the Tinkercad, if I'm having 2 Arduino Unos on it, which is my R3 Arduino Uno, I can select, so I have my Uno 1, which is here, and then I have if I drop it, I have my 2 here. So with the Tinkercad, you can choose to select. Now, I have my code written on the Uno 1. Let's see if I go to the Uno 2. Let's see if I'm going to get the same code. Now, with my Arduino Uno 2, there is no code. This is a different code that is automatically on it. So I'm not working with the Uno 2. I'm working with the Uno 1. But then, if it is you, you are only going to see Uno 1 because you are only having one Arduino Uno board on your circuit. So if you are doing 2, then you have to literally select the right board. And then if you are doing 1, you have to still keep with your 1. Now, this code has already been written, and then we intentionally wrote it just not to waste much of your time. So we have everything in our description on our Google Drive. So the link to our Google Drive is in the description. So make sure you tap in and then get your code. And then you can now copy your code and then paste your code here. But then I would like to explain this code a little bit. This is a code which is written in C++. C++ happens to be one of the fundamental coding languages that you would have to learn. Probably if you are doing somewhere around, something's around hardware and then much of computer programs. So C++ is a great language, and I always respect it. It has its rules and regulations. You don't violate it. You violate the rules, it also deals with you gently. Right? So I have my code written here, and then I would like to take you through my code a little bit, and I believe you can have a clear view of my code. Yes, so I have my initiation of or creating of variables. So I created my variables up here. Just as you can see, I created a variable called button pin, and then this button pin is literally my push button, and then I assigned it to pin number 11. So you can see I assigned it to pin number 11, and then if you come to my circuit here, I also made sure I kept the positive terminal of the buzzer of the push button to my pin number 11. So let's have a look. I have my push button, which is my highlighted. And then if you have a deep look, I have connected it to pin number 11, which is what you can see here. I've connected it to pin number 11. So this means that all connections should be made to the right host, because in the code we have assigned all our components to specific pin numbers. So I have my variables. I created my variables, and then I assigned my push button, which is my button pin, to pin number 11. My LED pin, which is for my red LED, to pin number 13. So if you carefully take a look at, you can see that the red LED has been connected to the pin number 11 on the circuit we just built. And then we have our buzzer, which is connected to the pin number 4. If you take a carefully look, that's what the last component we just connected, and it's also the same thing. Now, I created another variable here to store my push button state. So always, I want my code to reason a little bit to know the state of my push button, whether it's on or off. So literally, I created a new variable, and then I assigned the pin number 0 to it. 0 literally means nothing, right? That means my push button state has no power, and then it's 0. So anytime the logic I'm going to write is to make sure that I'm going to use an if-else statement. And then, so let me literally jump in so that you can understand what I'm talking about. Now, in my void setup, this is where I'm actually telling the kind of components I'm using. So this is a function that automatically, when you open your Arduino Uno, so those who are using the STEMAIDE Coder Kit, make sure you install your Arduino Uno IDE and then paste this same code. It's still the same thing. Try to select your board, and then you can upload your code. Now, when you open the Arduino Uno and then you automatically create a new file, you are going to see some things like the void setup function and then the void loop function. This is a function that is automatically created when you create a new file, and then it helps our code. It helps us make our code much easier and much faster. So it all has its functionalities. So this is where I'm going to put up my setup, and then I'm going to tell it my pin mode and then the kind of buttons I'm using. So pin mode means I'm initializing my pins to my code. I'm telling the computer the kind of pins and the kind of component So push button, which is my button state. Don't forget, I assign my push button to pin number 13. That is, I assign my push button to pin number 11. That is what I have here. But then here, I'm going to tell my code the kind of component that the push button is. So the push button is an input device. So it inputs or it takes, it can be used to input data. So I press on the button and then literally it tells my code the state at which my button is. So whether it's on or off. So it's an input device. And then I have my LED. My LED is an output device. It outputs light for me. It displays light for me to have a look. So probably LED is light, LED, bulb, everything you can imagine about LED. Yes. So I'm also telling my code that my buzzer is an output device. Buzzer bears sound. So probably my buzzer is also an output device. And then I now come to my main logic, which is my void loop function here. So in my void loop function is the main logic that you see. That is where everything happens. So these sites are just to tell my code the kind of components and how I have created their variables and how I've assigned them. Now, in my void loop function, this is where everything is literally happening. So I'm telling my code or my computer that the button state is equal to digital read from the push button pin. That means that I'm reading the button state, which is the push button state, whether it is on or off. So 1 means on, 0 means off. So I'm telling it the state at which my push button is. And I'm saying that anytime it's read, so I'm using this word, digital read. This is a word that has already been encoded in my IDE. So don't forget, IDE means Integrated Development Environment, and these are literally, normally I used to say softwares that you can use to create other softwares. They are kind of text editors that we can use to code and other stuff. So Visual Studio is one, Arduino Uno is one, the Arduino Uno IDE is one, and then code blocks and then many other IDEs are available. But then within this IDE, there are some specific functions that have been already coded into it. So I have my digital read function being coded into my IDE. So I have called it, and then I'm telling it to read the button state. So it's reading the state of the button, whether it's on or off. And anytime it reads the state of the button, it should store it onto my button state, which is the variable I created here. So the variable I created here, that is why I intentionally assigned 0 to it. So that anytime I'm reading in the state of the push button, I can store it, and then I'm going to use this thing. So I came here to write my if-else code, my main code here. That's where the whole logic function. So I'm saying that if my push button state is low, that means when my push button is off, when no one has pressed my push button. So the push button acts like a circuit. Anytime I press it, it goes and then allow electricity to flow through. And then anytime I unpress it or I take my hand off, it goes 0. So when I press, it comes 1, and then I unpress, it goes 0. So I'm telling my push button, I'm telling my code that anytime my push button state, which is the state I'm recording here, the digital read, anytime the state is 0, that means anytime the push button is pressed, I want it to literally turn on my LED. So anytime someone presses my push button, state goes 0, and then it should turn on my LED. And then if else, so I'm using the if else statement. So else, if no one has pressed it, then it should go high, right? So it's so simple. If someone has pressed my push button and then it comes on, automatically it will read the state of the button, and then if the state means that someone has pressed it, it will turn on my LED and then also turn on my buzzer, and then if not, it shouldn't turn it on. So I have my if-else code, just as you can see here. Ladies and gentlemen, this is a simple code. So all I need you to do is to get the code through our Google Drive the description to our the link to our Google Drive is in the description below. Make sure you get it, and then copy your code, paste it, and then after pasting your code, all we got to do is to stimulate our code. So I'm going to copy this code, and then I'll select my circuit here, which is my Uno board 2. So I'll come back to code, and then automatically I selected it. So it has aligned me to my Uno board 2. I'm going to highlight it and then paste it. So I come back, and then I start to stimulate. So the moment, first I come back and then go to my second Arduino Uno, copy, highlight it, and then paste my code. Now, the moment I paste it, I can start to stimulate my code. So if you were to be using the real-time circuit, so I am stimulating my code, and you can hear my push button and then my LED coming on. That's the same thing with my Uno or my original circuit. So I have my original circuit up here, and then the moment I start to stimulate it, you can see. So I'll choose my original circuit, stimulate it, and then you can have a look at it. So ladies and gentlemen, this is what we are supposed to build today, and I hope you had a nice experience, and then you have been able to make your way through. Try to fight your way through. At STEMAIDE, this is what we do. We teach you how to make these simple, basic electronic connections, because we understand that electronics is the backbone of technology, and we want you to understand the deep behind, or the concept behind this technology, so that in your career choice or in your career path, you can make right choices. We are moving into a world that is evolving much easy and then faster. So looking in the field of AI, looking in the field of new technologies, emerging technologies, where do you find yourself? How do you make more relevant or significant improvements in your career? And I would urge you to still reach out to STEMAIDE Africa, and then STEMAIDE is going to help you to find your ways to make good choices. At STEMAIDE, we just don't teach you, but we make sure we take you through the right career guidance. And yes, so ladies and gentlemen, without wasting my time, this is where we are literally going to say goodbye to our section for today. But I'm not just leaving that way. I am believing that you have been able to build your circuit in the right way, and have been able to upload your code in the right way, and then you have everything intact and it's working. If you happen to have any mistake or any difficulty, feel free to reach out to us on our WhatsApp channel. We have it in the description below. Make sure you join us, and then also try to share this to any loved one you love out there. We are going to keep this for some few days, so make sure you share it for the person to learn. Don't forget, we first dealt with our circuit. We also dealt with our LEDs. We dealt with everything. I tried to explain the code to you just to make sure you understand the necessity of this. And then these systems are some systems we use in our doorbells, we use in our homes. Anytime you go to someone's house that he has a doorbell on the gate, this is simply some of the systems that the doorbell technology is being built around. So this is actually like a basic doorbell technology. And the main focus of STEMAIDE is to make sure you understand the fundamentals behind this technology, so that you can also navigate and find your ways through this. So make sure you still head on to STEMAIDE for more information as on what I'm talking on. Yes, I have everything. So ladies and gentlemen, this is where I'm literally dropping the curtain. I want to make sure I make this much simple and simpler in such a way that you don't find anything difficult. So maybe you might not have had much information on what I'm talking about. Still don't hesitate to reach out to us. I have my WhatsApp channel on the description below, so make sure you get everything and then stay intact. Feel free to also contact me I'm on Instagram. You can search Lapi Joseph, and then you get me. You can contact me. Ladies and gentlemen, this is where we are finally going to say a goodbye to our section for today. I hope you had a nice time, and probably before I go, yes, don't still forget the STEMAIDE Coder Kit. This is a kit that contains the real-time component, as in how everything we built, yes. So I normally call it the lunchbox, the technology lunchbox. If you want to really understand the business behind technology, still go for STEMAIDE Coder Kit, and it's very affordable. I think this is one of the cheapest kits on the market currently. So, ladies and gentlemen, thank you for such a nice time. I don't want to waste much of your time. I've always promised to make this much easier, simpler, and then it's so simple. So make sure you head on to STEMAIDE, reach out to me if you are facing any difficulty. Thank you very much for today, and have a nice time.